Assalamualaikum and hi to everyone. Welcome back to my channel. So in this video we'll discuss about the transmission impairment. So transmission impairments mean the form of your signal, the original signal being changed through the during the transmission period. So signal travel through transmission medium or transmission media. So that transmission media is not a perfect transmission media, and that imperfection will cause the signal impairment. So this means that the signal at the beginning of the medium is not the same as the signal at the end of the medium. So during the transmission medium, your signal will be changed because of the imperfection caused by the transmission medium. So there are three causes of the impairment. We have the attenuation, distortion, and noise. So we look for the attenuation first. This one means that loss of the energy. So we have the original signal, for example, okay, during the transmission period, the energy drop. So it affect your original signal. And in order to overcome this impairment, we use the amplifier. So amplifier is used in order to strengthen your signal to back to the normal. Okay, it will amplify your signal to the original signal. Okay, the next one is distortion. So distortion means the change of the shape of your signal. Okay, for example, at the sender side you have this kind of signal, the shape of your signal. Okay, during the transmission, at the end, at the receiver side, the shape of your signal become like this one. So this one, the change of this shape we call as distortion. Okay, and the third one is noise. So noise is referred to the unwanted signal. So several types of noise. We have thermal, induced, crosstalk, and impulse noise. So during the transmission data, you have a signal. Okay, this one is the original signal. When it goes through the transmission medium, the unwanted signal will affect your original signal. So at the end, you will get this signal. Okay, we look at this example on how to calculate the signal to noise ratio, S and R. So basically the formula is S and R equal to average signal power divide to the average noise power. So example here, let's say the power of a signal is 10 milliwatt and the power of the noise is 1 microwatt. What is the value of the S and R? So we find the average signal power. So the signal power is 10 milliwatt, and then the noise power is 1 microwatt. So the power of the signal divide with the noise. So you will get the value of the S and R. So 10 milliwatt you change into the microwatt. So you will get 10,000 microwatt. Divide with 1 microwatt. This one is the microwatt, not the milliwatt. Okay, at the end you will get 10,000 decibel. Another example, the values of S and R for noiseless channel are equal to S and R signal power divide by 0 noiseless channel. So the answer will be infinity. So this part is not realistic and not logical. Okay, so this graph show about the two cases of S and R, a high S and R and the low S and R signal to the noise ratio. So this one we have the small S and R, this one we have the large S and R. Okay. So that's all for the signal impairment. So we have the attenuation, distortion, and noise. Noise at the noise part, we can have thermal noise, induced, crosstalk, and impulse noise or spark. So thermal means come from the random motion of the electron in the wire. Okay, random motion of the electron in a wire that create extra signal, so it will affect your original signal. The next noise is we call as induced noise. So this noise is come from sources such as motors or appliances that used during the transmission, any devices lah. Okay, the next part is the crosstalk. Noise come from the effect of one wire to another. Okay, we have multiple wires, so one wire and another might be being put together, so the unwanted signal from the other wires affect the other signal in another wires, so we call as the crosstalk. And then we have impulse noise or spike. So noise come from signal with high energy, so in very short period, high energy in very short period of the time, such as lightning. So this part we call as a spike or impulse noise. During those time, maybe 10 years ago, when someone call another number, it may heard another voice. We call that part is the crosstalk or noise. We want to let's say A want to talk with B, but suddenly A able to listen to what C is talking about, so that we call as the crosstalk to the line because of the unwanted signal. So that's all for the signal impairment. Hopefully you understand what is the impairment of the signal and how to calculate the noise based on the SNR formula. So that's all for this video. See you again in the next video. Assalamualaikum.